Vibe, I'll be vibing. Let me not feel like how do I
You gotta watch sport with the hitchhiker.
this whole guy thing. How is he like making all these? How is he making people
It's hard to explain. It's like
So who doing it?
throughout the entire movie. Who you hungry? Oh, it's a movie. And movie.
Okay.
How'd it go?
Right, how do you space?
It's actually.
How come there's no? How come?
Why would that
I watched it probably.
All right, if you would please, on your sheet, I want you to write down these 4 terms. Mass, weight, volume, and density. Okay? Write down these 4 terms. Mass, weight, volume, and density. And if you would, I want you to write your definition of each of them. Now, you don't have to be like, nailed it, this is the perfect definition. I want you to write your definition. Mass, weight, volume, density. Okay? These are 4 different things. Yeah, volume is the easiest. Do this on the back. Do this on the back of your leg. Oh, that's a great question. I love that girl.
What does that say? Velocity?
Density.
Someone needs to call her parents.
Mass, weight, now, I am not going to define these for you. We're going to talk, no. We're going to talk about your definition. So you need to write down a definition for each of them right now.
Oh shit.
How what? How dense something is? How
I really
dense?
just salad.
You cannot use the word in the definition of the word. That is a rule.
Oh, I thought you said Tashi alone. I was
Like, who is that?
like, I am gonna show.
I just want the salad and dressing.
Okay.
That's just the whole meal.
You ain't got some
No, because I want some pasta. I had some pizza.
So we definitely learned about these last year?
Really?
Did you? Did you learn about these last
I
year?
had the
What's quarantine?
yes.
Oh no. These are four different things. Hi. Here's here. So it says you're going to go to
Oh, and I had some. So what's that lemon?
The lemon vinegar?
the student. So let's say you're standing on the ground.
Two cups though.
Yeah, that's the rule.
And you're gonna throw the ball.
Because they know.
It's gonna go up
I've
like
been looking
this.
like,
Stop and stop, and then come back down.
This only feels
Does that make sense?
like.
When it gets up to the very top here, we want to. What are the values of the velocity and acceleration at this moment at the very top? Okay. So when you throw it up, what happens to the speed on the way out?
So weight is like
It slows down, right? And on the way back down, it speeds up. So what's the speed when you're at the very top?
yeah, it's a question to learn today.
I still really don't know where it's at.
Oh, well, a couple ways, okay? One of the ways is, we can relate it to something else. Remember when we pushed this car,
Yeah, I was much more.
right? And the car went up to the top, and then it came back down? What was true about the speed of the car at the very top here? If it slowed down and then sped up, what happened at the very top? It had to stop. Stop for an instant, right? So what was the value of the velocity when it stopped? Right? And then we know the value of the acceleration, no? It's up there. See, you knew you knew. I mean, I knew you knew. All right, you guys ready?
I'm so
Alright, let's, what?
I've drawn American flag, doesn't even work. It's called an American flag.
That's his thing. That's his thing. Alright.
That's a great thing to think.
Which one do you want to do first?
Density, density, density.
I think density is the hardest one.
That's the one I didn't get.
You're funny.
Which one's the easiest one?
Gravity.
The weight?
Oh, wow.
I think of weight or volume. Anyone that's not density. I know weight or mass, they both have something to do with gravity. It's still I still
No.
don't work.
Weight or mass has something to do with gravity. I agree with that. Let's do volume. Volume's the easy one. Tell me about volume.
How much, that's my definition.
Say it out loud.
How much space an object takes up.
Good. I'm okay with this. Volume is the amount
Did you say 3D?
yeah, so it's three-dimensional space. It's the amount of three-dimensional space an object takes up.
I was kidding.
So, I would say, yeah. What's up?
I got no density.
Well, let's do one at a time.
They do.
Why do they do that?
Well, because you get used to seeing better with your glasses when you take them off.
Thank you.
She's gonna be like, why are you wearing sunglasses? I'm like, man.
Can you see these two balls? Can you see these two balls?
Yes.
Which would you say is bigger?
Left.
Is this one bigger?
Yeah.
Which do you think occupies more volume?
What about right? Actually, I can't see the left.
Does this one occupy more volume?
Yeah.
Yes, it does. Now, normally when we use volume, oftentimes we use it as a like a liquid measurement. So if this was hollow and this was hollow, which one would you put more water in if you had to fill them up?
The left one.
That's right. So I think volume is a measurement of the bigness of an object. When you compare two things and you say that one's bigger, you mean it takes up more three-dimensional space. Is that okay?
Yeah.
Now, there are a couple ways to calculate the volume. Okay? There's a couple ways to calculate the volume. So let's take a three-dimensional object like this is called a rectangular prism.
Shut up.
Okay, listen, don't die. Don't die in physics. You gotta die in the hall. Here we go. So, you got a sense of this? Is that cool?
Yeah.
How do you calculate the volume of this object here?
Base time. Height.
Well, it's three dimensions.
Base width and height. Square. They usually give you
So, I'm gonna do length, width, and height. Yes. Length times width times height. Does that make some sense to you?
Yeah.
Is that cool? I'm not trying to stress anybody out here. Now, what I like about this, and this is just an aside, but could I measure this in centimeters?
Yeah.
So that means length measured in centimeters, width measured in centimeters, height measured in centimeters. So if you do centimeters times centimeters times centimeters, what's that?
Centimeters squared.
Also known as cubic centimeters. It's also known as cubic centimeters. You may have heard that term before. How do you find the volume of a sphere, do you know?
Like insert times pi.
4 radius.
4 with pi. And then circle square.
just tells you that a bigger radius would be a bigger volume, which you already had a framework for. But what I like about this is, if you measure this in centimeters, what are the units going to be?
Cube.
It's going to be centimeters cubed again. So that's why we know it's three-dimensional space. So the bigger an object is, okay? If I just look at these two right here, which of these occupies a bigger volume? This one does, right? And you know that because it's bigger. Okay. That was the easy one. Yes, it would also hold more water. That is true. What about mass? What do you think mass is?
The weight of an object.
So if mass and weight were the same thing, we wouldn't need two terms for them.
I don't know, it got something to do with gravity.
One of them definitely does.
That's weight.
Yes.
Mass doesn't like change with gravity, but weight does.
This is 100% true. She says your mass doesn't change with gravity, but your weight definitely does. Okay? If you take a bowling ball to the moon, it's going to be lighter, but it still has the same amount of mass. So what is mass then? Jensen.
The actual thing, something.
Okay. I actually don't mind this, and there's a way to talk about this. Now, we don't specifically have a way to measure this. Okay? We don't specifically have a way to measure this. Like, how do you know how much matter is in an object?
You get a scale.
So a scale will measure the weight of an object. What do you think the weight is then?
Gravitational pull.
Go ahead.
The effect of gravity on an object. Force. That's a big one. That's gonna help. You have to go like through nothing.
Boys, did I characterize your, what you said good enough?
Sure.
So it's the amount of force exerted by the Earth or some other gravitational body on an object. This is a measurement of the heaviness of an object. Go.
If you were like, had two different gravitational bodies like exerting gravity on you, would you weigh like more?
Well, it depends on where they were, right? But yes, they gravitational force adds. To that extent, I'll tell you something super random. Does the Earth pull on the moon?
No.
It does.
Oh, yes, yeah.
Okay. Here's how we know. The natural tendency of an object is to go straight. But the moon goes around the Earth, true? So if we look at this, okay? So here's the moon. Oh. Here's Earth. You don't need to write this down. the natural tendency of an object is to go straight. The moon should just go straight, but the reason it curves is because the earth pulls it in a little bit. Okay? Yeah.
So why does the moon affect the tides?
That's what I was going to say. Okay, this is such a great question. The earth pulls the moon in, but the moon also pulls the earth out. But
Or it
because,
pulls it, or would it push it out?
well, the moon is here, so it pulls the earth this way. So what ends up happening is an interesting thing, is that the water on earth will slosh over to the side that the moon is on. And so what ends up happening is, normally the earth is just water covered just like this. But when the moon is on this side, you get the water out here like this. And so we get a high tide wherever the moon is. And the thing that's really cool is that if the sun is also on the same side, let's say the sun is over here,